Hey, welcome back. This is Summer again from Alibaba Cloud database product team. Last week, we talked something about database security, and we also made two hands-on labs to introduce some tips to help you better manage your database and enhance your database security. This week, I'm going to talk about cloud managed Redis on Alibaba Cloud and hope you enjoy this video. If you like our contents, please give a like or subscribe. And arigatou gozaimasu. Yeah, thank you. Okay, next we'll start shortly. For better understand this content, I will switch over the camera and show my full screen, if you don't mind. Okay, I will see you there. Okay.
Okay, as you can see on my screen, the ApsaraDB for Redis right now supports Redis 4.0 and Redis 5.0. Later, we're gonna support the latest version, Redis 6.0, very soon. Actually, there are two families in ApsaraDB for Redis. They are Community Edition and Enterprise Edition, which is also called Tair. And for both editions, they have three major architectures: standard, read-write splitting, and cluster. For standard and read-write splitting, they're both in single-thread mode, by which I mean they only have one master node to handle all of the read and write requests. But for cluster, it's a little bit different because there are a lot of data shards included, or you can see there are a lot of master nodes to handle all of the read and write requests. Okay, we'll discuss these three major architectures later in this video. So let's skip to the differences between Community Edition and Enterprise Edition. Well, for Community Edition, it's more suitable for small and medium-sized applications because with the features that are compatible with open source Redis, but with higher reliability. And for Enterprise Edition, Tair is more suitable for performance-centric scenarios with features like data flashback, by which you can restore your data to any point in time, and two-way data centralization by using DTS, Data Transmission Service on Alibaba Cloud, and data tiering for hard keys and other values. In this way, you can have a cost-effective solution. And the last, rich additional modules supported, such as Blong, GIS, and others. Okay, next, let's see the three major architectures: standard, read-write splitting, and cluster. Let's talk about the standard architecture first. Well, there are two nodes included, one primary node and one replica. And only one node can respond to the request at the same time. In the first diagram, the clients and applications are interacting with the primary node continuously, and there is a HA mechanism to ensure the availability of the primary node. Once the primary node is done, the replica will take over within 30 seconds. In this way, the business will not be affected by the system failures. How about the data in primary node? Well, as is shown, your every write on the primary node will be synced to the replica asynchronously in a way based on the incremental logs, which is much improved compared with the native Redis. That's why using cloud-managed Redis can prevent you from issues caused by replication interruption that you may encounter if using the open source Redis. For example, when you are using open source Redis, psync will be called if the replication breaks. Once psync fails, the transfer of all RDB files will cause a large latency for the primary node. For more information about the comparison between open source Redis and ApsaraDB for Redis, please refer to the documentation I will show you in the description. Okay? That's it. The standard architecture is quite common and easy. If your workload is less than 100,000 queries per second, and you don't have strong desire for sorting and computing, then it's enough to deploy a standard master replica Redis instance. Then let's see what is read and write splitting. Well, if you fully understand the previous one, the standard architecture, then it will be very fast for you to understand the read-write splitting architecture. Look at the diagram in the middle. Comparing with the former one, the proxy layer and read-only instances are what make the read-write splitting architecture different. In fact, you can choose to set up at least one RO instance or 3 or 5 in max according to your real needs. The data will be synced to every node in an advanced method we just mentioned. So that means you don't need to worry about the consistency. And as the number of RO instances increase, the read performance grows linearly. Meanwhile, you will see that the primary node responds to all the write and partial read. That's account to the order splitting of read and write. You'll also see that the read requests are evenly distributed to the primary node and RO instances. If you get one replica, the weight will be 50% each. If you get 3, it changes to be 25% each. If you get 5, then it changes to be 60% each. So, for read-write splitting architecture, what is the best scenario to choose it? And what is actually useful? Well, as it contains only one primary node but several RO instances, so it's definitely suitable for write-light but read-heavy applications. And since the max spec is 64 gigabytes, it's also a good choice for those who want to use Redis as a persistent storage with the requirement to compatible with Redis native commands. Next, let's talk about cluster architecture. As we said before, it's pretty much different from the standard and the read-write splitting architecture because the first two are still in a single-thread mode, while the cluster is in a multi-thread mode, which is absolutely a historical innovation for Redis. Basically, the cluster inherits the core idea of distribution. When the number of requests is too many for a single thread to handle, divide and process separately, which is also the value of sharding. Every shard is an independent processing unit, which I mean the data is stored separately, and there is no such thing like latency between every primary node or with the data shard. And for each shard, like standard architecture, there is a HA mechanism to ensure its availability so that they can all handle read and write requests at the same time. Okay, talking about connection, both proxy mode and direct connection mode are supported. For convenience, we recommend to use proxy mode. In addition, you can choose to set up a cluster with at least 2 shards or scale to a maximum of 256 shards for a total of 1496 gigabytes. This is pretty much cool. Then, the last question, when and where you should choose the cluster architecture. In no doubt, you should use cluster architecture when a 64 gigabyte single thread architecture cannot meet your needs of storage or performance anymore. For example, the QPS keep growing, even extend tens of millions. Well, when it's necessary to use cluster, since there are a lot of enterprise features integrated, we recommend you to use Tair cluster instead of the cluster of Community Edition. Okay, that's all for today. Thank you for watching, and I will see you next time. Bye!